Hi class, and welcome to Lesson 9.1, Line Plots. Let's begin by looking at our essential question. How can a line plot help you find an average with data given in fractions? Well, let's begin with our unlock the problem. It says, students have measured different amounts of water into beakers for an experiment. The amount of water in each beaker is listed below. So we have 1/4 cup, a 1/4 cup, a half a cup, 3/4 cup, 1/4 cup, 1/4 cup, 1/4 cup, 1/2 cup, 1/4 cup, 3/4 cup, 1/4 cup, 3/4 cup. So if the total amount of water stayed the same, what would be the average amount of water in a beaker? So let's begin with figuring out what it is we have to answer. And that is the question we just read. If the total amount of water stayed the same, what would be the average amount of water in a beaker? And our question actually has one of our key words, our key word being average. Now, how do we go about solving this type of problem? Well, let's begin by taking it step by step by step. So, step 1 says to count the number of cups for each amount. Draw an X for the number of times each amount is recorded to complete the line plot. So let's go up and count. We will begin with the 1/4 cup. So we see 1/4 cup, 2 1/4 cups, 3 1/4 cups, 4 1/4 cups, 5 1/4 cups, 6 1/4 cups, 7 1/4 cups. So we have 1/4 occurs 7 times. Now, so as we don't get confused, we can actually go up and cross out each of those 1/4 cups so we don't accidentally count it again. Now, let's look at the next one. It has us counting the half cup. And we see that we have 1 1/2 cup, 2 1/2 cups, and that's all I'm seeing. So we can go over here to 1/2, and we can actually put an X for 1 1/2 cup and an X for 2 1/2 cups. And it looks like we need to go back and finish our 1/4. It'd be 5, 6, and 7. So now we can come down here to our half a cup and put the 2. We can go back up to our chart and mark off the half a cup because we've used those. Now, let's look at the last one, is our 3/4 cups. So we come back up here to our data and we look at the number of times 3/4 shows. It's 1 3/4 cup, 2 3/4 cup, 3 3/4 cup. We can come over here and finish our line plot. So it would be 1, 2, 3. And it shows the 3/4 3 times. So let's mark that off so we don't get confused. Now let's look at step 2. What does step 2 tell us to do? Find the total amount of water in all of the beakers that contains 1/4 cup of water. So there are, according to our data over here, there are blank beakers with 1/4 cup of water. So we know that there were 7 beakers with 1/4 cup of water. So there are 7/4 or 7/4, or if we take our 7/4 and divide it out, our fraction greater than 1, or our improper fraction, we see that 1 times 4 is 4 minus 3. Our denominator stays the same, so it's 1 3/4. So 1 3/4 cups. Now let's look at step 3. Step 3 says find the total amount of water in all the beakers that contain a half a cup of water. So there are 1, 2, or like we have here, so there are 2 beakers with a half a cup of water, so there are 2 halves or 2 halves, and we know when the numerator and the denominator are the same, that's going to equal our whole number of 1. So let's look at step 4. It says to find the total amount of water in all the beakers that contain 3/4 cup of water. So we have 1, 2, 3, or like we have here, 3. Or we can set it up as a multiplication problem. We put our whole number over 1. 3 times 3 equals 9. 1 times 4 equals 4. And if we divide that out, 9, our numerator in the house, divided by our denominator, is 2 times 4 is 8, minus, and leaves at, which 4 is the denominator, so it becomes 2 and 1/4. Step 5 then has us add to find the total amount of water in all of the beakers. So then we can add our 1 3/4 we got from our step 2, our 1 that we got in step 3, and our 2 1/4 that we got in step 4 together. And when we add those together, we get 1, 2, 3, 4 as our whole number, and 3 plus 1 is 4. We know when we add or subtract fractions, our denominator does not change. 4 and 4/4 then equals 5. So our last step then is to divide the sum you found in step 5 by the number of beakers to find the average. Well, our answer in step 4 was 5, which is where this one comes in. And then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's going to be 5 divided by 5 divided by 12, which is going to equal 5/12. And you know that you can do that by taking and doing the inverse operation. So it'd be 5/1 times 1/12. 5 times 1 is 5. 1 times 12 is 12. Now let's take a look at another problem. It says to try this. You can use the order of operations to find the average. Solve the problem as a series of expressions that use parentheses and brackets to separate them. Perform operations from inside the parentheses to the outer brackets. So let's begin. Our problem is set up with a bracket in parentheses 7 times 1/4 plus 2 times 1/2 plus 3 times 3/4 divided by 12. So if we begin with the first step, 7 times 1/4, we know if we put our 7 over 1, that becomes 7/4. And then we know that 2 times 1/2 equals 1, and 3 times 3/4, remember to put our whole number over 1. 3 times 3 is 9/4. Then when we add all of those together, we get 5 divided by 12. And we know that we do the inverse operation, and that is going to equal 5/12. Okay, let's look at the next example we have. It says, Rain divides 3 2-ounce bags of rice into smaller bags. The first bag is divided into bags weighing 1/6 ounce each. The second bag is divided into bags weighing 1/3 ounce each. And the third bag is divided into bags weighing 1/2 ounce each. So we're going to find the number of 1/6, 1/3, and 1/2 ounce rice bags. Then graph the results on the line plot. So, first step is to write a title for your line plot. It should describe what you are counting. So we are going to go with, down here on our line that shows what we are counting, the weight of rice bags. Now, once we have our title in place, we will come up with step 2. It says to label the 1/6, 1/3, and 1/2 on the line plot to show the different amounts into which the 3 2-ounce bags of rice are divided. Now you see that they've already done that step for us, so then we can move to step 3. It says use division to find the number of 1/6 ounce, 1/3 ounce, and 1/2 ounce bags that were made from the 3 original 2-ounce bags of rice. So we have 2 divided by 1/6, 2 divided by 1/3, and 2 divided by 1/2. So when we do the inverse operation, we know that that becomes 2 times 6 equals 12. So we know that there were 12 1/6 ounces. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. With our second one, we know that doing the inverse operation, we have 2 times 3 equals 6. So there were 6 1/3 ounce bags. So it would be 1, 2, 3, 4, 5, 6. And then the next one was 2 divided by 1/2. Well, with the inverse operation, it becomes 2 times 2 equals 4. And there were 1, 2, 3, 4, 1/4, or I'm sorry, 1/2 ounce bags. Now, step 4 says to draw an X above 1/6, 1/3, or 1/2, which is what we just did. And that will finish our line plot. There will be no notes or no password for tonight's lesson because this is something that we're going to delve more into during class tomorrow. So be sure you record your answers from today's lessons in your big math book and bring it with you to class tomorrow. We'll see you then.